I actually forgot. Yes, now I'm recording. Thank you. Yeah, so find and simplify F composed with G and G composed with F. So as I said, this is exactly similar to the homework problem fee in the homework fee. Review. Okay, but then you have to actually have to simplify your answer. Okay, so oh okay, I see. Oops. So now I guess, I mean, for homework number 3, which is due, as I said, Monday night. We covered, problem number 1. So now you're supposed to know how to do the problem number 1. This is a problem number 3. Similar to the problem number 3 in the homework number 3. And then after this, we're gonna do something similar to the problem number 4 in the homework 3. And then we're going to do something similar to the problem number 2. Okay, so I think we have time to cover everything you need for homework number 3. Rabiu, you got the first one. Let's see. Yes, that's very good. Yeah, that's that. Excellent. Sing -4. Yes, I guess your -4x square. Yes, Xing, you're right. Sean, plus 8x square. I think it should be. I think it should be -22x, not -26. But I mean, I don't really have the answer, but I think it should be -22x. Lorden, you factor out the 2, right? Okay. Yeah, Sean. So Sean, it should be -22x actually. Yes. Yeah. So Lorden, I think your answer is correct. Rabiu for number 2, yes. That's very good. All right, guys. So I guess probably you're done with this exercise. Does anyone need more time? Okay, probably not. All right, so let's start with the F composed with G, right? So F composed with G of X. So this is by definition F, and then between the parentheses it's G of X. Okay, so what we do, guys, so we take F of X, which is 2x squared minus x plus 1, and we just substitute x by g of x. So this x here by g, and this x here, so this is this x by g, and this x here also by g. All right, so then there's a 2 here, and there's power 2, there's this minus, so it's minus, and then, sorry, and then plus 1. So that will be equal to 2. So my g is between parentheses. As I said, you think of the circle as a parenthesis. So that's like, so we have g inside the parentheses. So g is the 3 minus 2x, and there is a square minus, because we have this minus here. So this is minus, and then again, g between the parentheses. So that's 3 minus 2x, and then this is plus 1, right? This is plus 1 here, so I'm going to keep the plus 1, of course. So let's see. So this is 2 times, so this is like 3 minus 2x times 3 minus 2x minus, yes, Lorden, for number 2, your answer is correct. Minus 3 minus 2x and then plus 1, right? So make sure that, guys, when you distribute, be careful just with the sign, right? So anyway, so here let's just multiply by 2, like 2 times 3, and this 2 here times this 2. Lisbeth, yeah, Sean, Lisbeth, both you're correct. Yes, it's minus 4x squared minus 2x plus 1 for G composed with F. Yeah, very good. So that'll be 2 times 3, that's 6. 2 times 2, that's minus 4x. Okay, and there's this 3 minus 2x here, and minus 3 minus 2x plus 1. So I'm gonna just try to distribute again. So this 6 here times 3, 6 times the 2x, and then 4x here times the 3, and then times the 2x. So that's 6 times 3, that'll be 18. There's a minus, so here's my minus 6 times 2, that's 12x. And then minus 4x times 3, that's minus another 12x. And then minus, that will be a plus. So this is plus 4x times 2x, that will be 8x squared. Okay, and then here it's minus 3, and then minus, that will be a plus. So it's plus 2x, and then finally you have this plus 1 here. Okay. All right, now we can try to simplify. So let's see how many x squared. We only have 8x squared. Okay, so that's 8x squared here. Now, how many x's? So let's see x's. We have minus 12x, that's minus 24, minus 24x, and there is this plus 2x, that will be minus 22x. So we have minus 22 x's. Now, what about the constant? We have 18 minus 3, that's plus 15, plus 1, right? So that will be plus 16. Okay. And then, well, of course, you can, if you want, I mean, the answer here is correct, but you can, if you want, you can factor out 2. Okay, so that'd be like 2 times 4x squared minus 11x plus 8. Okay, so that's the final answer. That's the F. So answer F composed with G, it's actually 8x squared, or 2 times 8x squared minus 22x plus 16. I think all of you got this right answer. If I'm not, oh yeah, there's yeah, oh well, Rabiul, I think you have minus 16 for some reason, but it should plus 16. I think it should be plus 16.
I
Anyway.
wasn't sure about the minus 2x.
Oh, okay. All right, so now the G composed with F, guys. Now, let me write again the F of X. Okay. So F of X is, let me write it again. It's 2x squared minus x plus 1. So it's 2x squared minus x plus 1. And then the G of X is just 3 minus 2x. All right, that's, if I'm not mistaken, that's my G. All right, so now we need to find G composed with F. So this is find G composed with F. So that's, by definition, that's G of F of X. Okay. Now, how do you compute G composed with F? So first, you write down G of X, and so we substitute this X with this F of X. Now, what's G? G, as I said, it's just 3 minus 2x. So it's 3 minus 2x. So we have to substitute this X. There's only one X right here. And you have to substitute that X with the F. So now it's like 3 minus 2fx. All right, so let's compute this thing here, 3 minus 2. And then the circle, as I said, it's really important that you put parentheses instead of the circle. So inside the parentheses, that's f, and f, here's my f, right? So that's 2x squared minus x plus 1. And now I have just to distribute. So this is 3 minus 2 times 2, that's 4x squared, minus, that would be a plus 2x, and then minus a plus, that would be minus. So that's minus 2. So final answer, let's see. So how many x squared? Well, we have just minus 4x squared, just 2x. And then the constant, we have 3 minus 2, that would be plus 1. Okay, so find answer. And as you can see, guys, f composes g. I mean, it's very different from g composed with f, right? The two functions are just not the same. So it's minus 4x here, x squared, sorry, plus 2x plus 1. All right, so, and as I said, so that's very different from, f composed with the g was the 8x squared, etc. And this is my g composed with f. So they're not equal in general. All right, is there any question about this composition? Nope. Okay, perfect then. Now, guys, now we're gonna use graphs to find like a sum or some or product or composition of functions. So next, so we're gonna use graphs. So use graphs. Okay, to find f plus g, f minus g, etc. Okay, so let me give you example first. All right, so let's say we have the graph of two different functions. So here I have my function f is 1, this is 2, this is -1, and this is -2. And here I have my function g. Okay, I'm going to need the -2, I'm going to need -1, 0, of course, and then 1 and 2. And here, let's say I'm going to need 1, this is 1, and this is 2. So 1, and here is 2. And I'm going to need -1 here, and same here, I'm going to need -1. All right. Anyway, so let's say if graph of f is the following. So the graph of f is this one here. This is -1. Right, this is f of x. Okay, now I have another function g of x. So my function g is the following. So this is g of x. Okay, now so let's say you want to find. So I want to find. Let's see. So f times g of 1, f plus g of 2, f minus g of 0, f over g of 2, okay, and then let's say g over f of 2, right? Here, let's say you want to find f composed with g of 1, and then g composed with f of 1, f composed with f of 0, and then g composed with g of 0, and finally f composed with g of 0. So this is very similar to the problem like 4 in homework fee, right? This is so homework fee problem number 4. Okay, guys. So what I'm gonna do, I'm gonna show you how to find like the first ones, and then you're gonna do the rest. Okay, so I'm gonna show you how it works. All right. So like f, this is f times g, right? The dot, it means multiplication, right? F times g of 1. So I mean, f times g is like f of x times g of x. Okay, but the thing is, my x is 1. So here, when I write f times g of 1, it means f of 1, right, times g of 1. Okay. So then what will be the answer? Well, what's f of 1? Well, f of 1, you check the graph. So f of 1, that's -1, right? As you can see from the red graph, f of 1, as you can see here, f of 1, it's -1, right? So this one here, it's -1. Now, times g of 1. So what's g of 1? Well, g is the blue graph here. So here's 1. So g of 1, it's +1, right? So this thing here, this is +1. And so what will be the answer here? Well, it's -1 times +1. So the answer is -1. Okay. So you see what I did, guys? So f times g of 1, it's like, so f of 1, you need to find f of 1 first, multiplied, but yes, Elizabeth.
For example, the first
Yes.
of we have like -1, right? And the second one is 1. So then we multiply 1 or 1 and it's -1. We multiply.
Oh yeah, for this one here, yes, we multiply. This is multiplication.
Okay, we do the multiplication.
That's a multiplication. Like for the next, it would be addition, right? This is a plus. Here it's a subtraction, right? Here it's division. Then you would divide, right?
Okay,
But here this is a dot, so it's a multiplication.
I got it. Thank you so
Okay,
much.
this is
The multiplication.
yeah, multiplication here. Okay. Okay. So is there any question, guys? How I got this -1? I just so you find f of 1, you find g of 1, and then you multiply. All right. Yes, Rabiul, that's the so okay, so I guess that's how it works. Like for if you had a plus, then there'll be like -1 plus 1. If you had like subtraction, you're gonna subtract. If you have a division, there'll be like -1 over +1, right, etc. Now I'm gonna show you how to do the composition. Okay, so now I'm gonna show you how to do this this thing here. Okay, f composed with g of 1. All right. So okay, how does it work? Well, f composed with g of 1, guys, that's probably I'm gonna need more space here. Okay, I'm gonna just explain in the bottom here. I need space, I guess. So f composed with g of 1. So my x is 1. But anyway, yes, Lisbeth.
Sorry, Professor.
Yeah, no problem.
I saw that Rabiul put the answer, right? But what
Rabiu,
we to sum, he put 0. Why his answer is 0? You're not supposed to put 4?
well, because f, well, this is f plus g of 2, right? So first you need to find f of 2. So what's f of 2? What do you think? What's f of 2? So here, so Rabiul is talking about the next one, right? This f plus g of 2.
Yes.
So that would be like f of 2 plus g of 2, right? Because we have a plus, right? This is a plus here.
Uh-huh.
So we have a plus. And the x, it's 2 here. It's not 1, right? The x is different. We have a different x. We have different input.
Yes, it's 2.
Yeah, it's 2. So that would be f of 2 plus g of 2. And then, so then you have to find f of 2 and g of 2, and then you have a plus, right? You have the addition. So first, what's f of 2? What do you think? What will be f of 2?
0.
0. And
Okay.
yes, and g of 2 is also 0. So that's why Rabiu said the answer would be 0, because it would be like 0 plus 0.
Yeah, I was confused in that part. Thank you so much.
Sure, no problem.
Mm.
Okay, guys. Okay, so now let me just explain how the composition works, okay? Because it's kind of different from the addition, subtraction, etc. So for the composition, like for the first one, I have this F composed with G, right? So again, by definition, it's like, I'm sorry. So it's like F. Oh, come on, sorry. So it's like F composed with G of 1. So my x is 1. So instead of f of g of x, it's f of g of 1, because x is 1, right? So now what you do, guys, so be careful. This is not a multiplication here. I mean, here there's no dot. It's not multiplication. It's a composition. Okay, this is not, again, this is not not a multiplication. Okay, it's a composition. So it's f of g of 1. It's not f multiplied by g of 1, right? So so let me just emphasize here. So this is f of g of 1. Okay, so how do we do that? Well, so here it's like it's like we are using PEMDAS rule. So what we do is, first we have to find or evaluate what's between the parentheses. So parentheses comes first, right, in PEMDAS rule. So between parentheses, I have g of 1. Okay, so I'm gonna find g of 1. So what's g of 1? Well, g of 1, it's, well, from the graph of g, as you can see, g of 1 is 1, right? So g of 1 is 1. So here, this g of 1, I'm saying it's 1. Okay. G of 1 is 1. G of 1 is 1. All right. So now I'm done with the g. But there's an f outside, right? There is still f outside. Okay. So now I have to evaluate f of 1. Okay, because now I got this 1 between the parentheses, right? So now I have to find f of 1. And what's f of 1? Well, we check the graph of f. F of 1, it's negative 1. So that then the answer, final answer here would be negative 1. Okay. So as I said, guys, so here you have to do what's inside the parentheses. So inside the parentheses, I have this g of 1. So I have to find g of 1. All right. So once you got g of 1, there's still f outside the parentheses, right? So then you evaluate f of 1, which is a negative 1. And as I said, it's here. There's no multiplication. It's not a product. It's so it's a composition. All right. Is there any question, guys, about how I got this f composed with the g of 1?
Yes, please repeat again, because I was writing down the.
Okay.
I was explaining. Sorry.
No problem. So I was saying, so this f composed with g of 1, so it's by definition. So you put f first, and then parentheses, and then you have g, right? That's by definition. Like f parentheses g of x. But my x, as I said, my x is 1. So here it's g of 1. Okay. And then I said, this is like a PEMDAS rule. You have to find what's inside the parentheses. So inside the parentheses, I have this g of 1. Okay, I got this g of 1, right? So I have to find g of 1. So you check the graph of g, and the g of 1 turns out to be 1. Okay, so now inside the parentheses, so this g of 1, it's actually 1. Okay, but you are not done yet because there is still f outside. And now I have to find, right, there's this still this f here, right? There's this f here. Okay, so now I have to find f of 1 because I got 1 between the parentheses, so there's a f outside, so that's like f of 1. And f of 1, if you check the graph of f, that will be -1. So as you can see here from the graph of f, that's f of 1 is -1. Okay. All right, guys, I'm gonna let you find the other answers. So please, so this for this one we got, so we got this answer here, it's actually -1. Okay, so please try to find, okay, please try to find the rest, okay? I see Rabiul. Yes, yes, because f of 0, let me see what you are saying. F of 0 is undefined. Why is that? F of 0 is not undefined, Rabiul.
Because there is no intersection. F of 0, there is no intersection, I think.
I mean, no. This is like a full.
Okay, it's 2, right?
Sorry.
It's 2.
It's 2. Yeah, this is like a full circle here. Yes.
Oh, okay.
It's
2. Yeah.
2. That's a full circle. I mean, there's it's just yeah, it's a full
yeah,
circle.
I get it now. Yeah, it's 2.
Mm-hmm. Yes.
Let me just ask you something. So on the first one, you don't put the values in like you said, it says equal f of 1 by g of 1, right? So you put the numbers on top. You put -1 and 1 on top.
Yeah, that's because like f of 1, you see here's sorry. So you see here this 1, right? So f of 1 is this -1, right? That's why I put the -1 in the top of f of 1. And then g of 1, so here's 1, and then g of 1 is +1, right?
Yeah, that's what I'm saying. So you don't put the numbers like where you have the
No.
circle. You just put f1 and g1 and the
Yeah,
answer.
yeah. Sure. So yeah, absolutely. I mean, I was trying to explain there. Yeah. So like here should be like, like negative. Oops. Should be like -1 times 1, and then so the answer is -1.
Okay, I see.
Mm-hmm. Probably I need more space here. That's annoying, actually. Yes, Rabiu, g composed with g of 0 Yeah, g of -1 is undefined. Yes. Let me see what you're saying. Sean, f over g of 2. Let me see. F over g of 2. Yes, very good. Yeah, very good, Sean, because we are not allowed to divide by 0. Very good, Sean. Yes.
Thank you.
Rabiul, g of 0. Yes. Yeah, correct, Rabiul. All right, guys. Does anyone need more time? Okay, probably not. All right, that's good. Right, so for next f, we have f plus g of 2. So that's by definition, it's a plus, so it's addition of f of 2, f of x plus g of x. My x is equal to 2, so that's like f of 2 plus g of 2. And that will be equal to, so now I need to find f of 2. So f of 2, well, it's just 0. So that would be 0. So that would be equal to 0 plus, and then g of 2 is also 0 because, as you can see here, here we are here at 2, and so g of 2 is 0. So this is 0 plus 0, which is equal to 0. Right. Next, f minus g. So this is like f of x, but my x is 0. So that's like f of 0 minus g of 0. So now I need to find f of 0. So what's f of 0? Well, let's see.
2.
2,
Okay.
very good. So this is 0, and so f of 2, as you said, it's 2. So that's 2 here, minus, and then g of 0,
Minus 1.
minus 1, very good. So it's minus, and then parentheses, minus 1. Then minus would be a plus, okay? So that's like 2 plus 1, and that will be, so 2 plus 1,
Great.
and so the answer, it's 3.
So wait, what was 0 on top? Wasn't it 2 plus 2?
Oh,
The
no,
the,
no,
sec-
no,
the
no,
second
no, it's not, no, it's not 2 plus 2. It's f of 2 plus g of 2. And f of 2 is, it's 0. This is 2, right?
Okay, I see. I see.
So,
I see.
you see here, f of 2 is 0.
All right, I see.
Okay, f of 2 is 0. It's not 2. It would be 2 if it's like here, right?
Yeah, like f of 0.
Yeah, yeah.
I get it now.
Yeah, Sean. Yeah, Sean, I think you're as probably the last two are incorrect. Actually, G composed with G and F I think that would be undefined. We'll see. Now F over G. So it's like F of 2 over G of 2. Now, what's F of 2? That's the 0. And the G of 2, well, it's also 0, right? Because here's 2, and so G of 2 is 0. So 0, we are not allowed to divide by 0. So that's the answer. So the answer, Eliani, which
the-
negative one?
For the one on top, the 2 minus
The one in the top, the first one, F of 1 times G of 1.
-1 for the f, the 2 minus.
You are breaking up, I think. I don't really hear you. So you're talking the last one. Oh, no, last one I got. You mean the f minus g? Oh yeah. Why it's -1? The third, yeah. So it's 2 minus -1 because g of 0. This is 0, right? So then g of 0, it's -1. So it's like 2 minus -1. And 2 minus -1 would be 2 plus 1. That's why it's equal to 3. But you see, here's 0, right? So, and you need g of 0. So g of 0 would be this point here, which is -1. I mean, the corresponding y would be -1. Okay, I hope this answers your question. Okay, perfect.
Professor, just really
Yes.
quick, this is Tiffany Rodriguez. I have to change my Wi-Fi, so just in case it lags off, I'm gonna log right back in, okay?
Okay, thank you.
What's wrong with the
Thanks for letting
internet? I
me-
can't really hear you.
Okay, thank you for letting me know. Thank you. Yes, yeah, the f of 2 over g of 2, guys. As I said, the g of 2 is 0, and we are not allowed to divide by 0. So the answer here, it's actually undefined. This is undefined. Well, I don't have the space, but it's undefined here. Okay. Probably I'm gonna erase this because I'm gonna need. Okay. So yeah, for f over g of 2, that's undefined because we are not allowed to divide by 0. So this is, oops, g composed g 0. I'm gonna need space here, so the answer here is undefined. So this is g composed g of 0. Okay, so the answer there is undefined. And the last one, g of 2 over f of 2 here, well, it's again 0 over 0, so the answer is also undefined. Okay. All right, now next, well, next it's this G composed with F of 1. So I'm going to do it like in the bottom here. Okay, so let's forget about this. All right, so we're gonna do this G composed with F of 1. So again, by definition, it's G of F of X, but X is 1, so it's G of F of 1. Right? And then, as I said, it's like PEMDAS rule. We need to do what's inside the parentheses, and inside the parentheses, I have F of 1. Okay, so that's G. And now, what the question is, what's F of 1? Well, F of 1 is, let's check the graph. F of 1 is -1. Right, so that's G of -1. Okay, so again, there's this G outside, right? So now I have to find G of -1, and well, G of -1, well, there's like an empty circle at -1, so G of -1, it's undefined. So the answer here is undefined. So this is undefined. Okay, as you can see, guys, so here's my G. You keep the G, but you evaluate F of 1. So F of 1 turns out to be -1. And then there is this G outside, right? So that's like G of -1. And so that's undefined. Next one in the list, so G composed with F. Now F composed with F of 0, right? So you can also compose F, a function with itself. So F composed with F of 0. So it's like F first and then parentheses, and inside the parentheses we have F again of X, but X is 0, so that's like F of 0 here. Okay, so between the parentheses I have F of 0. So the question is now, what's F of 0? Well, let's see the graph. What's F of 0? Well, F of 0 is 2, right? So here inside the parentheses, I'm gonna have 2. That's F of 0. That's the value of this thing here, right? That's 2. But then there's still F and F outside, right? So now I have like F of 2. Now let's see what's F of 2. So the answer would be, so what's F of 2? Well, F of 2 is 0. So the answer is 0. So this is equal to 0. Okay. So that's F of 0. Now G of 0. Now G composed with itself. G composed with itself of 0. So it's like there's a G outside and there's a G inside the parentheses, and the X is actually 0. Now, so let's find first what's inside the parentheses. Inside the parentheses, I have G of 0. Okay, and there's a G outside, and here's my parentheses. So inside the parentheses, it's G of 0, which is actually G of 0, it's
-1.
-1. Thank you. So -1. So this is actually -1. Okay. And again, there's still a G outside. So that's like now it's like G of -1. And G of -1, it's, well, no, it's actually undefined because there's this empty circle at -1, right? So G of -1 is undefined. So this is the answer here. It's, oops. So the answer here is, this is undefined. Right, because
Why is it
again,
-1 again?
so it's G of G of -1 is undefined because there's an empty circle here, but it's -1 because well, we had the G of 0, right? First we had G of 0.
No, I understand. I was just looking at the graph. It's fine. Thank you.
Oh, okay. All right, and then a lot last one, f composed with g of 0. So it's like f composed with g of 0. So first we have f, right? Then parentheses, and then inside the parentheses we have g of x, but my x is 0, so it's g of 0. Right, so again, so first we need to find g of 0. Okay, so first we need g of 0, -1, thank you. So that's -1. And now I got f of -1, which is, well, f of -1 is 0. And so as you can see here, well, here's my point, f of -1 is just a 0. So the answer here would be 0. Right?
Wait, we're not multiplying?
No, well, that's the thing. We are not multiplying here. There's no multiplication here. It's a composition.
Yeah.
Right?
No, the F and, wait, the F and G, it's just,
Here, right?
no,
You're talking here.
yeah,
About,
yeah,
no, that's the thing. That's not f times g. That's f of g of 0. The space there, that's off. Like f of what's inside the parentheses, g of 0. So it's not f dot. It's not f multiplied. I mean, that's not f dot. It's not multiplication there. That's the thing. It's not multiplication. It's just composition. So all you have to do is just to keep the f. Keep the f, right? There's this f here, and you evaluate what's inside the parentheses. Like here, we had g of 0, and we said g of 0 is -1, right? And then we have like f of -1. It's not like f times -1. It's like f off, right? This space here, that's off. F off -1.
You're not doing any operation. You're just moving the numbers, right? I guess.
Yeah.
Pretty much.
Yeah.
So yeah.
I could have sworn we did that for the first one. We multiplied.
Yeah, that's different. So yeah, that's the thing, because you see this first one here, we had this dot. So that's f multiplied by g. That's
Right.
That's multiplication. This dot, right? We're talking about this dot, I guess, right? This one.
Okay, well, actually, the FOG one. I mean,
This here,
F composition G one.
compose. Where? Which one?
No,
He's talking about the first one for the compositions.
The first one about composition. Oh, okay,
Yeah.
this one here.
Yeah.
Yeah, it's composition. I mean, I think I did it right. I explained the answer for this, but yeah, it's the same thing. It's like for G composed with F, or there was no multiplication.
It's pretty much just putting the value of f of 1 on the other parentheses, keeping the g, and that's it. I guess.
Okay. All right. Okay. All right.
I mean, I can do it again. So this is F composed with G. Sorry, it's not F composed with G. It's where is it? Yeah, F composed with G of 1. So it was like, so F composed with G of 1. It's like, so F of G of 1. It's not F times G of 1. And then this is F, and then here this is G of 1. G of 1. What's G of 1? G of 1, it's like 1. All right. So G of 1, it's 1. And this is 1 here. And so now it's not like F times 1. It's like F of 1. And F of 1, I think it's a -1. So that's the answer we got.
Okay. All right.
Next. Okay.
I was multiplying the whole time.
No, yeah, that's the thing. That's why I said earlier that I know some of you are kind of confused with this composition. It looks like a multiplication, but it's not. I mean, by experience, I know. I mean, it's confusing, but yeah, I mean, it is what it is, All right, guys. Is there any other question about this composition? So that's how, so this is, so whenever you have graphs and, you know, you have to find the sum or subtraction or wherever, or composition. So that's how it works, okay? And this is exactly, this is similar, this is exactly like a problem number 4 in the homework feed, okay? You have exactly like the same problem. 2 graphs of f and g, and then you have to find, you know, et cetera, et cetera. All right, so if there is no question, so now let's just cover the last thing you need for the homework, which is for the homework number 3, which is actually domain. Okay, so next, guys, so we have all these operations, right? Sum, subtraction, multiplication of or division of functions, etc. So now the big question is, what's the domain of, so next, so we're gonna try to find the domain. So if you have a function f, we discussed how we find the domain of a function f, right? Remember, we had these 2 rules. We are not allowed to divide by 0, and we don't have negative numbers under the square root, right? That's how we find the domain of a function f. Now, if we have 2 functions like f and g, 2 different functions, the question is, what will be the domain of like f plus g or f times g, etc. So now the big question is, what's the domain so given f of x and g of x, so we have 2 functions, and the question is, what's the domain of f plus g, f minus g, f times g, and then f over g. So because now we know how to add, subtract, multiply, divide functions, so next thing we're gonna do is we're gonna try to find the domain of you know, these operations. And then of course next time we're gonna try to find the domain of the composition of 2 functions, okay? Because composition of 2 functions is harder, so I'm gonna keep it for the next time. But let's start with the f plus g, f minus g, f times g, etc. So yeah, so to answer this question, I need to introduce so the answer here. So to answer the question, so I need to explain, we need to understand, or we need to understand or to find the common domain of for 2 functions. Okay, so what's this common domain? I mean, common domain for 2 functions is just the intersection. It's the intersection domain of the 2 functions. So so the common domain so that's the intersection. It's just the intersection intersection domain of the 2 functions. Okay. So what do I mean by this intersection domain? So here's an example. I'm going to show you an example. And so you can see what I mean by the common domain or the intersection domain. Okay, so here's an example. Okay, so let's say we have two functions, f and g, and let's say domain of f of x is, okay, for example, it's negative, let's say it's negative v positive infinity. Okay, and let's say domain of g of x is let's say negative infinity 0, 0 included. Okay, so I have these two functions, f and g. I know that the domain of f is negative 3 positive infinity, and I know that the domain of g is negative infinity 0. So so the question now it's what will be the common domain or the intersection domain of these two functions? So what's the intersection domain or what's the common domain? The common domain, not exactly, Yani, it's not negative 3. So what's the common domain? Nope. Nope, it's not 0, Rabiul. So let me explain. So I'm going to use number lines here, okay? So for f, you know, this is negative infinity, this is a positive infinity. So the domain of f, let's say here's a negative 3 somewhere, here's 0. So the domain of f is negative 3 excluded. So we have like parentheses here, and then all the way to positive infinity, right? This is a domain of f of x. Okay. Now the domain of g. So I'm gonna draw another number line. Okay, domain of g. It's let me just put again negative 3 and 0 here. Domain of g is negative infinity to 0, 0 included. So negative 3 to 0. Right, so this is the domain of g. Yes, Tiffany, yeah, you're absolutely right. So now what's the intersection? So the common domain, as I said, they have common domain, it's just the intersection of the two domains. So the question is, so you know, the domain of g is this one, right? So I'm going to draw the domain of g here on the same number line as f. And so the intersection is the interval which is colored by the blue and purple at the same time. And that will be the intersection, right, of the two domains. This is my G here, right? So the intersection would be the interval which is, you know, colored by blue and purple at the same time, right? So that will be this domain here, this one here, right? That will be the intersection here. And the 0 is included, and a negative 3, it's actually excluded. Okay, so that's my common domain or intersection domain. So common domain in this case, so the common domain is, that will be negative 3. Negative 3, of course, is excluded because, you know, negative 3, it's in the domain of G, okay? It's in the domain of G, right? But it's not in the domain of f, right? Because for f, we have to exclude negative 3, right? So it's in the domain of g, but not in the domain of f. So it's not a common value to the two domains, right? So it's not in the intersection. Negative 3 is not in the intersection because it's not in the domain of f. So we have to exclude the negative 3, right? And then the 0, what about the 0? Do we include the 0 or not? Well, the 0 is included in G, right? And it's also included in the domain of F, right? Because 0 obviously is in the, you know, between negative 3 and infinity. So 0 belongs to both domains, right? So it's a common value, so it's included. Yeah, very good, Tiffany. So 0, it's included. So we use a bracket here. So again, this means the bracket means it's included. Just to explain here the notation, and the parentheses, it's excluded. So the common domain is just, the intersection between the two domains, right? I mean, if you have a trouble with the common domain, guys, my advice for you is just to, you use the number line, and then you can color, the two domains and see what's the intersection. Okay. Okay, so that's what I mean by the common domain. And now, well, first, is there any question about the common domain? Do you see, guys, why the common domain would be -3, 0, with -3 excluded and 0 included?
Just to
Any
verify,
thoughts?
when a dot is filled, there's included, right? Or I'm bugging. On the graph,
Yeah,
let's
so
say.
it's yeah. The bracket. You see the bracket here?
So if the
It
bracket
means
will be,
included.
all right.
Yeah, bracket included. The parenthesis is excluded. Yes, Lisbeth.
Okay, so for example, for the first one, the numerator of x, right, is -3 plus infinity.
Yes.
Our answer, we have to put the excluded and the included on our final answer. That is -3, 0, right?
Yeah, -3, 0. The -3, it's excluded because, as you can see, -3 here, it's excluded from the domain of f. So it doesn't belong to the domain of f. So if it doesn't belong to the f, so then it's not common to the f and g because it's not in the domain of f. So it's not a common value, right? That's why it's, as you said, it's excluded. The 0, it's in the domain of G, right? Because of the bracket here, it's in the domain of G. And it's also in the domain of F, right? Because, you have 0 here between -3 and infinity. So 0 is like common to both domains, right? It belongs to F and it belongs to the domain of G. So it's common value. That's why we include the 0 with the bracket.
Okay, thank you.
Mhm. Is there any other question about the common domain or the intersection domain? All right, so sometimes it's not always obvious, guys. Actually, I mean, sometimes you need really to draw your number line and try to see what will be the intersection between the two intervals, right? Anyway, so once you know what's a common domain, then we are good to go, and then I can actually say what's the domain of f plus g. So this is let's say a theorem. Okay, so let's say you have two functions. So be two functions. Okay. Then the domain of f plus g, f minus g, or f times g is the common domain to f and g. Okay, so what I'm saying here is that if you have two functions, f and g, so we are supposed to know how to find the domain of f. We know how to find the domain of g. And what I'm saying is that if you want to find the domain of f plus g, we don't have to compute f plus g. Okay, all you have to do to find the domain of f plus g is to find the common domain, the intersection domain to f and g. Same for f minus g or f times g. You don't have to compute f minus g or f times g to find the domain. All you have to do is find domain of f, find domain of g, and then take the common domain or the intersection domain. Okay, now that's for f plus g, f minus g, f times g, and the last thing, the f over g, the domain of f over g. Well, the thing here, because we divide by g, so we have to exclude the values of x where g is 0. So is the common, it's the common domain with common domain with values where g of x equal to 0 are excluded. So you take the common domain and you exclude the values where g of x equal to 0, because we are not allowed to divide by 0. That's the only difference with the domain of f plus g, f minus g, f times g. So for f over g, you have to find the common domain, but then find an answer. In the final answer, you have to exclude the values where the denominator is 0. Okay. So let me do a couple of examples. All right. So examples. Okay. Right. So first example, let's say I'm gonna take square root. All right. So this is so if you check the homework number 3, so I think it's that will be problem number 2, where we have to find the domain of f plus g, f minus g, etc. So this is like homework 3, problem number 2. Anyway, so so let's say f of x is square root of x plus 3, okay, and g of x, let's take both of them like square root. So g of x is square root of 1 minus x, okay, and let's say you want to find the domain of f plus g, let's say f minus g, f times g, and f over g. All right, this is exactly like the exercise in the problem in the homework. Of course, different functions, but the same question. All right, so how do we do that? Well, first step, you don't have to compute anything. You don't have to compute f plus g or f minus g, or f dot f times g or f over g. Okay, you don't really care about the sum or the subtraction, etc. So first step, you have to find the common domain. So you want to find the common domain because that's what the theorem says. The theorem says that the domain of these operations, it's actually the common. It's basically the common domain. So so what we have to do, so like step 1, we have to find the domain of we have to find the domain of f first, let's say. So find domain of f, and we know how to find domain of functions. So find domain of f. In the step number 2, you need to find the domain of g. Find the domain of g. And the third step, you find the common domain. Find a common domain, and that will be the domain, and that will be the domain of f plus g, f plus g, f minus g, and f times g. Okay. Now, for f over g, we need to exclude for f over g, okay? So we exclude where g of x equal to 0 from the common domain. From the common domain, okay? Now, let's follow these steps, okay? First, so step 1, we need to find the domain of f. So step 1, I'm gonna find the domain of f. So what's the domain of f? Let me write down f for you guys. F of x is square root of x plus 3. Okay, now let me remind you, how do we find domain of a function? As I said, as we discussed, I think 2 days ago, you have to ask yourself, is there a division or is there a square root, right? So there's no division here. So no division, that's good. No division. Okay, but we do have a square root, right? There is a square root. So we have to solve what's under the square root, okay, larger or equal to 0. Okay, so what's under the square root? Well, under the square root, we have x plus 3, just x plus 3, right? So we have to solve the x plus 3 larger or equal to 0. Okay. So that's just subtract 3, from both sides. So then x is larger or equal to negative 3. Okay, so this is, again, this is larger or equal. Larger or equal. Okay, so my x is larger or equal to negative 3. So what will be the domain of f? So the answer here, domain of f, just to explain. So this is my negative 3, positive infinity, negative infinity. And what we are saying is that my x is larger or equal. So it can be equal to negative 3. So I'm going to include the negative 3, right? Because it can be equal to negative 3 and it's larger than negative 3. So then domain of f would be like negative 3 included positive infinity, which is always excluded. Okay. So that's our domain of f. Okay, well, now step number 2, the domain of g, right? The g is the square root of 1 minus x. So step number 2, I'm gonna find domain of g, and then in the step number 3, we're gonna take the common or the intersection domain. So g of x is square root of 1 minus x. Okay, again, check if there's a division. There's no division. Okay, that's good. That's good news. But now we do have a square root, so we have to solve. So we have to solve what's under the square root larger or equal to 0. Okay, so under the square root we have this 1 minus x, right? So we have to solve 1 minus x larger or equal to 0. Okay. Well, you can just here, I mean, you can subtract 1 if you want, but I'm gonna just add, it will be easier to just add x plus x both sides, right? So then that will be 1 on the left, larger or equal to x, okay? So 1 is larger or equal to x, right? This one here cancel out, so it's just positive 1. So what will be the answer? So the answer, domain of G, So I'm gonna just draw again a number line for you guys so you can see what I'm talking about here. So let's say here's one, a negative infinity, positive infinity. And so what we are saying is that here, what we are saying is that one is larger or equal. Okay, so one is bigger or larger than or equal to x. So which means that x is on the left side of one, right? Because one is larger than x. So it's on the left side of one, and it can be equal to one, right? Because of this line here. So I'm gonna include one. Okay, so domain of G would be like, you always go from left to right, from the smallest number to the largest number. So it's, you start from the left, which is negative infinity, which is always excluded, and to one, which is included, of course, because x can be equal to one. All right. So I got domain of F, I got domain of G, and now I have to find the intersection domain or the common domain. Okay, so in the last step, step V, we're gonna find the common domain. Well, so what's the domain of F? So I'm gonna draw a number line for you guys. So for F, we said domain of F is, well, it's a negative 3, positive infinity. So it's negative 3. Oh, sorry, this is negative. So domain of F, it's negative 3, positive infinity, negative 3 is included. So this is the domain of F. Okay, this is f of x. Okay. Now, what's the domain of G? We just said domain of G, it's negative infinity, positive 1, right? So I'm gonna use a different color, of course. Let's use green. So negative infinity, positive 1. So negative infinity, I'm gonna need positive 1 here, somewhere here. So negative infinity, positive 1. So as you can see here, positive 1 is included. Okay, so that's the domain of G of x. Okay, so what will be the intersection? So which interval is at the same time red and the green? Well, that will be this interval here, right? It's green and red at the same time. So it belongs to the domain of F and domain of G, right? And yes, Rabiul, absolutely. And negative 3 and positive 1, both are included. Okay, so the intersection domain would be this one here. Okay, that's the common domain. So so the common domain, as Rabiul said, so common domain would be negative 3, positive 1, and both are included because yes, that is Beth. So both are included, negative 3 and the positive 1. All right, so you got your common domain, you're almost done. So then the answer to the domain of F plus G, F minus G, F over G, sorry, F times G. So here, the answer to the domain of F plus G, F minus G, F times G is the common domain. So it's negative 3, positive 1. Okay, so this is for the domain of F plus G, F minus G, F times G. Now, there's for F over G, we have to exclude from the common domain the values where G of X is 0. Okay, so for domain of F over G, because as you can see, guys, we're gonna divide by G, right? So we have to exclude where G is 0 from the common domain. from the common domain. So now the question is, where g of x is 0? Common domain. Okay, so where g of x is it's a square root of 1 minus x, right? So we have to solve, we have to see where this g of x is 0 and exclude the values from the common domain. So, well, g of x is just square root of 1 minus x, right? So we have to solve square root of 1 minus x equal to 0. So we're gonna solve for x. So we can just apply square both sides. So it's just 1 minus x equal to 0. And so then your x, 1 minus x is 0, so x is equal to 1. So we have to exclude this from the common domain to find the domain of f over g. So we have to exclude. So we have to exclude this from the common domain. So what's the common domain? Common domain is, so the common domain, as you can see, guys, the common domain is just -3, +1, right? Both -3 and +1 are included. Now, what I'm saying is that for the domain of f over g, we have to exclude +1 because that's where the g is 0, and we are dividing by g, so we are not allowed to divide by 0, of course. So so the domain, so this is the answer for domain of f over g. So domain of f over g is -3 included, but then we have to exclude the +1. Okay, so we have to exclude the +1. So +1 excluded because that's where the g is 0. Okay, so that's the only difference, between the domain of f over g and the rest. Is there any question? I mean, it seems like it's a long, but actually it's not that bad. I mean, if you know how to find the domain of f, you know how to define the domain of g, then actually what you have to do is just to take the common intersection domain. And once you have the intersection domain, you're almost done, right? Is there any question, guys, about this example?
No.
No? All right, so here's an exercise for you then. All right, that's good. So exercise. So I'm gonna give you two functions. Let's see, two nice functions. All right, so let's say f of x is square root of x plus 1, and g of x, I'm gonna say g of x is, let's see, no, probably, yes, okay. No, let's take a fraction and the square root. Okay, let's take f of x. F of x is 2 minus x over x minus 3, and g of x is square root of x plus 25, and then there's minus 5 outside. Okay, so please try to find domain of f plus g, f minus g, f times g, and f over g. So as I said, guys, here you don't have to compute anything, the f plus g, f minus g, etc. Okay, you have to focus on the domains, right? Find a domain of f, find domain of g, and then take the common or the intersection domain. All right. So just to remind you here, don't compute. You don't have to compute the f plus g, f times g, f over g. Okay, it's actually useless. Okay, The steps would be like step one, find domain of F. Then of G. And then 3, find the intersection or the common domain. Find intersection domain or common domain. All right.
Professor,
Yes, please.
can I ask you a quick question outside of this?
Yeah.
For homework number 1, what is the question you're asking for the numbers 3 to 5 under the graphs? I'm just a bit confused at what is that I'm supposed to look for.
Like for the blue graph.
Like you see, for the bit.
F of -3,
Yeah.
F of -5, F of 4.
Yes,
yeah,
what's
so-
the question I'm answering?
Yeah, so you have to find like the corresponding output. So like, okay, let me just give you an example here.
Okay.
So like, just taking like a random example. So let's say you have a graph here, okay, and whatever here. This is my f of x. So what I'm asking for is like find, let's say, f of 1. So then it's like you have to find the corresponding output. So like this is my x is 1, right? This is x is 1. So this is x is 1, and so f of 1 would be like here, it would be like 4, right? That's the
Okay.
answer. Mhm.
Okay.
So
okay.
that's what you have to find.
Okay,
Yeah.
I just wanted to make sure I was answering
Yeah,
the right
sure.
question. Okay, thank you.
Mhm. And one more thing, actually,
Yes.
be careful. So you have like a circle, like let's say here I have -2, okay?
Yes, that's not included, right?
Yeah, that's not included. So then like f of -2 would be like undefined, okay?
Oh, okay. Okay, thank you. That makes sense now.
Mhm. Oh, you're done, Rabiul? Oh, wow. Okay, let me see. You're saying 3 -25. Well, first, Rabiul, we always go from left to right, like from the smallest number to the largest number. So probably, so you mean here, I guess, -25, 3. But I don't think so. I don't think, let me see. Nope, no, your answer is actually incorrect. Are you sure about the domain of F? What's the domain of F? I think you made a mistake with the domain of F. So just to remind you guys, I mean, if you want to find the domain, so there are two things. If you have a division, then you have to solve the bottom, the denominator equal to 0, and that you have to exclude these values from the domain, okay? And if you have a square root, then you solve, wherever you have under the square root larger or equal to 0, okay? So division, you solve the denominator equal to 0, and then for the square root. Yeah. So for the domain of F, so obviously F is I mean it's a fraction, so there is a division. So you solve the denominator equal to 0. So as I said, it's that's when x is 3. So we have to, so the input x can be any real number except 3. So you have to exclude 3 from the domain of F. Just 3, only 3. Nope, nope, Xing. Actually, I think you're, nope, Xing. Actually, I think you made the same mistake as reviewer. So yeah, be careful with the domain of f, because f, you have a division, and all you have to do is to solve the denominator equal to 0, not larger or equal to 0. It's equal to 0, and you exclude that from the domain of f. Actually, this is a good exercise because you know, we have square root and we have division. So like the domain of f would be like any real number except the 3. You just exclude 3 from the domain of f. So any real number except 3. Not I guess you said yes. That would be the domain of f, Rabiul. Yeah, that would be the domain of f. Yes, that's the domain of f. Yes. Nope, Sean. You also made the same mistake. Nope. So I think you made the same mistake. So that the domain of f, because it's a division, so you have to solve just the bottom equal to 0, and you exclude that from the domain of f. So you don't solve like the bottom larger or equal to 0. Just solve the bottom equal to 0, and you exclude that from the domain. So you just exclude the f. Sorry, the 3. So like domain of f would be any real number except the 3. Oh, that's your no, and let's see. Nope, that's actually not correct. If yes, Darian, you got the right answer. I think no, wait, Darian. Why do you? Oh yes, yes. Darian, you're correct. Yes, now Xing, you're correct. Lisbeth, you have to exclude the 3. So so it would be like as Darian and Xing said there will be negative 25, 3 excluded, because you have to exclude 3 from the domain of f. So okay, so you know, guys, we have like 6 minutes left, so I'm gonna try to solve the problem, go over the problem in the last 6 minutes. All right, and then next time we'll see. Probably gonna have one more example or something. Okay, so let me go over this before we end the meeting. Okay, so so step 1. So yeah, so domain of f, as I said, so f of x is just, you know, 2 minus x over 3 minus x. Oh, sorry, x minus 3. So yes, Lorden, you're correct. Yes, Lorden. So here, guys, for domain of f, there's a division, and in the case of division, you just solve the bottom denominator equal to 0. Okay, so just solve the x minus 3 equal to 0, because we are not allowed to divide by 0. So we have to exclude the values of x for which the denominator is 0. So we solve x minus 3 is 0, which is of course then x is equal to 3. So we have to exclude x equal to 3 from the domain of f. Okay, so the answer here, domain of f, So domain of f, you know, you have your number line, you have negative infinity, you have positive infinity, you have phi somewhere. And what I'm saying is that x can be any real number except the phi, because that's the value where the denominator is 0. Okay, so domain of f would be negative infinity, phi excluded, union with phi positive infinity. And again, phi is excluded, of course. So that would be the domain of f. Okay, so division, it's different from the square root. So in step number 2, the domain of g, which is square root of what was the square root of what? Square root of yeah, x plus 25. Sorry. Yeah, so it's x plus 25 minus 5. There is a minus 5 outside. We don't care about the minus 5 outside. There is a square root, and so we have to solve what's under the square root larger or equal to 0. So there is a square root. So square root, come on. So there's a square root. So we have to solve what's under the square root, right? Which is x plus 25, larger or equal to 0. Okay, like I did in the what I did in the previous example. So that's then you subtract, you take away 25. So then x is larger or equal to negative 25. So the domain. So the answer here with domain of g . So here's my number line. Here's negative 25 somewhere. This is negative positive infinity. So we are saying x is larger than negative 25. So it's like you go from negative 25 to positive infinity, and negative 25, x can be equal to negative 25. So we include the negative 25. So the answer here, domain of g would be negative 25 included, positive infinity. All right. Now, in the last step, step 3, in the step 3, we take the intersection domain. So common domain, I hope I'm gonna finish before I have like 1 minute. I'm sorry, guys. I want to finish this before a common domain. So here's my number line. Here's my negative 25. There is a 3 domain of f. We said domain of f is any number except the 3, right? That's the domain of f. This is my f. Domain of g, it's any number larger than negative, equal or larger than negative 25. So here's the domain of g, right? So then what will be the common domain? So the common domain.
25, negative 24.
Yeah, so negative 25, as you said, included. But then be careful, because the 3 is excluded from the domain of f. So it's not common to f and g because it's excluded from f. So it doesn't belong to the domain of g, right? Doesn't belong to the domain of f. So it's not a common value. So we have to exclude the 3. So the 3 is excluded. And then we start again after 3. So that's 3 excluded to positive infinity, right? Because we do have intersection here, right? It's red and green at the same time, right? And positive infinity, of course, is excluded. So that's the common domain. And so that's the domain of f plus g, f plus g minus g, f times g. That's this negative 25 p union with the positive infinity. Last, just one word about the f over g. So for f over g, so we have to solve where g of x is 0. So g of x, which is the square root of 25 plus x, I think minus 5 equal to 0. So if you solve this, you're gonna get x equal to 0, right? So we have to exclude this from the common domain. So we have to exclude it from the common domain, and that will be the domain of G over F. So, sorry, F over G. So the answer for F over G, I'm gonna finish with this. Domain of F over G is, so negative 25, and then we have to exclude the 0. That's where the G is 0. So 0 excluded, union 0 again to 3, union with 3 positive infinity. Okay, that's the domain of F over G. I'm sorry, guys, we went over time. Probably next time I will do one more example or exercise about this common domain. All right.
Thank you, Professor.
Thank you. Yes, yeah, that's only for that one. Yes, Diane, yes. Yes. Yeah, Mia. Okay, I got you. Thank you. Thank you, everyone, and good night, and
Good night,
enjoy
Professor.
your
Have a good
weekend.
night,
Right?
Professor. Enjoy your
It's
weekend.
gonna be beautiful tomorrow, so enjoy your weekend.
Have a good night. Enjoy your weekend.
Good night. Thank you,
Everybody,
everyone.
good night.
Take care.
Bye.
Bye.